Good morning, everyone. All I'm going to go over this morning is just showing you guys how to search for bad characters. Now, when you take over a server, a lot of the times, depending on the protocols, um, certain hex characters can cause your input to do stuff you do not want it to do, such as carriage returns and this sort of thing. So I'll take you into my server now. I've already broken into the server. I have control of the EIP, and this is the um, exploit I have here. So I've already filled the buffer with our A's. I've overwritten the EIP, our return address, just with B's. And then we had a bit of an offset, which I'm going to jump ESP, but there was an offset from where the ESP's placed. So we put in a couple extra C's there. And then I've already filled below the return address 600 bytes, so I do have enough for my shellcode. Now, before I put shellcode on and jump right into taking this server right fucking over, we need to check for bad characters. So, what I'll do, I just have a list here of all the characters possible that we can send, and we'll send it and we'll see if it causes any unwanted behavior, like once it gets to 0xa, which is a line return, and then a carriage return, we're probably going to have some issues. Once you get into this, you'll start knowing what ones cause trouble. But that's part of the fun. And this is probably the most time consuming of the exploit that we're doing here today. So I've already got my server set up with my window bug attached to it. So let's save our file here. Okay, so let's launch this against our server. And as you can see, evil buffer is done. So let's go check our server. I'm RDP'd into our server. Whoops, I didn't start the server. And here we go. So we're crashed. So as you can see, EIP is overwritten with our B's. That's my placeholder for my jump ESP in a little bit. So we can do display bytes of ESP minus 10 with a length of 20. Let's see if that will work. Okay, so as you can see, here's our buffer A's, our B's over our EIP, and here's the start of our C's that does an offset for us right there. And now we can start seeing where our bad character lists got placed onto the stack. And as you can see, it goes up to 9, and then we get a null byte here. So let's have a look at our bad characters. And as you can see, 0xa. So what is 0xa? 0xa is a line feed, okay? And it moves the cursor down one line. So what happened by feeding this in, we discovered that this character causes problems. So we will cut this character out. I will add this to my list here, and we will file, save this again. We come back in, let's and go to services and restart our server. And we will attach with WinDebug as the administrator and attach process to our SyncBreeze server. Here you go. Now let's run the exploit again. And this is why it's so time consuming, because you have to go through and find every single character that causes us issues. Minus 10, length 30. Okay, so as you can see, 0B, we took out 0A, which was the line return. And as you can see, 0B, 0C is fine, and then we get a null byte. So let's have a look at our list again. So 0D is causing the trouble here. So we will cut this out of our payload, and we'll add this to our list. And now this is what we do. We go right through and make sure that any bad characters are taken out. Now, so why do we do this? When we're making our payload or we're picking any of our gadgets, any of these characters will cause the program to not, or our input to not work. So we have to take all these characters out, and then we have to build our payload and make sure our gadgets don't have any of these characters. So I have a bit more to do, but I figured I'd show you a bad character analysis just so you guys have some awareness of it. And I'll be doing a lot more of this stuff in the coming weeks. So I hope you enjoyed, and I'll get chatting to you guys soon. Bye.